A fierce November storm rattles the windows of a suburban home in Jacksonville, Florida. Inside the kitchen, Elizabeth Ross is comforting her young daughter, trying to ignore the growl of thunder outside. Suddenly, a brilliant flash of lightning floods the room white. In the eerie quiet that follows, Elizabeth rounds the corner towards the stove and freezes in her tracks. There, hovering right in front of her stove, is a glowing sphere of light the size of a grapefruit. It's a perfectly round ball, shimmering white-blue and humming softly like a high-voltage power line. It hangs 3 feet off the floor, drifting ever so slightly. Elizabeth's heart leaps. For a moment she wonders if she's seeing things. The orb crackles and pulses, lighting up the kitchen walls with an unearthly glow. She doesn't dare move closer, but she can't look away. The ball of lightning, for what else could it be, is mesmerizing and terrifying all at once. In the back of her mind, she remembers stories of fireballs during thunderstorms, but nothing could have prepared her for this otherworldly sight in her own home. Without warning, the sphere expands, doubling in size, its light intensifying to a blinding brilliance. Elizabeth flings up a hand to shield her eyes. A massive boom shakes the entire house. The windows rattle in their frames. Startled screams ring out down the hallway, her daughter calling for her. In that split second of chaos, the glowing orb vanishes. Elizabeth rushes to check every room, expecting smoke or fire. Nothing. No scorch mark, no broken glass, just the pungent scent of ozone and sulphur hanging in the air. The kitchen is dark now, lit only by the flicker of lightning outside. Everything is as it was, except for Elizabeth's pounding heart and the memory of that floating ball of light seared into her mind. She knows she didn't imagine it. She saw a ball of lightning in her kitchen, an electrified phantom that appeared and disappeared in mere moments. As the storm subsides, one question refuses to leave her. What on earth just happened? For centuries, people around the world have reported encounters like Elizabeth's, mysterious orbs of glowing light that appear during thunderstorms. These fiery spheres are said to hover or drift unpredictably, sometimes slipping through windows or chimneys, even bouncing along the ground before either silently fading out or exploding with a bang. They're usually only visible for a few seconds, but those few seconds leave witnesses awestruck and often deeply puzzled, even frightened. What makes ball lightning so fascinating is that it defies our expectations. Ordinary lightning is a blinding flash that lasts a split second, streaking jaggedly from sky to ground. But ball lightning is lightning shaped like a glowing ball, floating serenely as if it had all the time in the world. It's no wonder early witnesses struggled to make sense of it, or that even today in the 21st century, scientists still don't fully understand it. Ball lightning has been described as white, blue, yellow, or even red-orange, ranging in size from a small pea to a basketball or larger. Most accounts describe it during or right after a thunderstorm, often right after a lightning bolt strikes nearby. The glowing sphere might appear in the air where the lightning hits, or even indoors as if sneaking along wires or through cracks. It typically lasts longer than a normal lightning flash, 2, 5, or even 10 seconds of eerie illumination. Then, as mysteriously as it came, it disappears. Some balls of lightning wink out quietly, others burst with a loud pop or bang, sometimes leaving behind smoke, the smell of burnt sulphur, or tiny scorch marks. And the strangest part? Nobody sees where it comes from. One moment there's nothing but the storm, the next moment a ball of fire is floating at eye level. There's no obvious source, no wire shorting out, no magic lantern. It's as if the storm itself briefly gave life to a sphere of electricity that roams free. Over the years, many have wondered, is ball lightning even real? Or is it just a myth, a trick of the eyes during storms? The phenomenon is so rare and fleeting that for a long time it lived on the edge of believability. Many scientists remained skeptical, insisting that balls of fire were either exaggerated tales or simple misinterpretations of ordinary lightning. After all, extraordinary claims require extraordinary evidence, and for most of history, evidence of ball lightning was only anecdotal, stories passed down with no photograph or hard data to prove these wandering fireballs actually exist. Yet the stories persisted from culture to culture in strikingly similar detail. People who had never heard of ball lightning were describing essentially the same phenomenon: a luminous sphere, a thunderstorm, a sulphurous smell, an inexplicable disappearance. The consistency of these reports and the credibility of some witnesses gradually convinced scientists that something real must lie behind the legend. Ball lightning, it appears, is real, just exceedingly elusive. And so we're left with a tantalizing mystery. What exactly is ball lightning? How can a ball of light sustain itself longer than a split-second flash? What is it made of? And could it pose a danger, or perhaps even be useful, if we understood it? To unravel this, we'll journey through the history of these ghostly orbs, from medieval chronicles to modern laboratories, and explore the many theories, from the plausible to the downright spectacular. Along the way, you'll hear how scientists have chased this will-o'-the-wisp of the storm, trying to pin down an explanation. And ultimately, we'll see what the latest evidence suggests about how nature might create such a strange phenomenon, and whether we're any closer to solving this electrifying puzzle. Reports of glowing balls and storms go back hundreds of years. One of the earliest known accounts comes from an English monk named Gervase in the year 1195. In his chronicle, Gervase described witnessing a marvellous sign in the sky near London. During a thunderstorm, a dense dark cloud emitted a bright white sphere, a sort of fiery globe he called it, which fell from the cloud and plunged into the River Thames. This medieval monk likely had no concept of ball lightning, but his description is unmistakably similar to what modern witnesses report. If Gervase's account is to be believed, people have been seeing these floating fireballs for at least 8 centuries. Fast forward to a Sunday in October 1638 in the village of Widecombe in the Moor in Devon, England. The local church is packed with worshippers when a massive thunderstorm bears down. Suddenly, as eyewitnesses later recount, a great ball of fire bursts through a church window amidst a crash of thunder. The fiery globe ricochets around the church interior, tearing a hole in the roof, shattering pews and scorching the walls. Panicked congregants watch in horror as the rolling fireball strikes down several people. According to one account preserved in the church, 4 people were killed and dozens injured in that infernal moment. Some victims were found with their clothes oddly unscathed, a chilling detail that would later make scientists wonder about intense electromagnetic effects. The event was so inexplicable that villagers blamed it on the devil himself riding in on the storm. But modern historians and scientists consider the Great Thunderstorm of 1638 to be one of the earliest probable cases of ball lightning striking a building. Over the years, more such tales emerge. A British sea captain in the 1700s writes of a glowing globe rolling along his ship's deck during a storm, frightening his crew. In 1753, a German scientist named Georg Rickmann met a tragic fate while experimenting with a lightning rod in St. Petersburg, Russia. As he observed an electrical storm in his laboratory, a ball of bluish-white fire reportedly formed on the rod, shot into the room, and struck Rickmann in the head, killing him on the spot. His death by a thunderball became widely known, lending serious credibility to the phenomenon. If a trained scientist could be killed by a ball of lightning in a lab full of witnesses, surely this was a real physical occurrence, not just peasant folklore. By the 19th century, the term ball lightning was in use, and more scientists and adventurers reported encounters. In ballrooms, kitchens, and open fields, the stories came from all over. Often these glowing spheres seemed almost playful yet menacing. One account from the 1800s describes a luminous ball skipping along a ship's mast, another of a fiery orb bouncing down a chimney into a cottage, then quietly dissipating in front of a stunned family. In an era of rapid scientific discovery, such accounts spurred debate in royal societies and scientific journals. Was ball lightning a new kind of electricity, a form of burning gas, or just overactive imaginations? One particularly intriguing chapter of the ball lightning saga came during the Second World War. Allied aircraft pilots flying night missions over Europe and the Pacific began reporting mysterious orbs of light trailing their planes. These glowing balls would appear out of nowhere, keep pace with the aircraft, and sometimes zip around the wings before vanishing. Pilots, thinking these could be some form of enemy weapon or aircraft, nicknamed them Foo Fighters. And yes, the rock band took their name from this phenomenon. It's very likely many wartime Foo Fighter sightings were actually ball lightning or a related atmospheric electrical phenomenon. Imagine being a pilot in a dark sky, seeing a bright sphere suddenly pop into view in the cockpit or just off the wingtip. You'd be both alarmed and mystified. On at least a few occasions, ball lightning appeared inside aeroplanes. One anecdote describes a ball of light materializing in the cockpit during a storm, then calmly drifting down the aisle past white-faced passengers before it disappeared. Frightening? Absolutely, but when the plane landed, there was no damage at all. By the mid-20th century, ball lightning had graduated from legend to a genuine scientific puzzle. Researchers around the world, from the United States to the Soviet Union, started paying attention, collecting reports, and even conducting studies. The US Air Force got interested, partly because if ball lightning was real, it might pose a hazard to military hardware, or be something enemies could spoof. In 1963, after a series of aircraft-related sightings, the Air Force Cambridge Research Labs commissioned a physicist named Edmund Dewan to study the phenomenon. Dewan's approach was to gather the stories. He put out a request in newspapers asking anyone who had seen ball lightning to write to him describing what happened. He received dozens upon dozens of letters, vivid eyewitness testimonies, which he compiled into a report titled Eyewitness Accounts of Kugelblitz, using the German word for ball lightning. These ranged from farmers, sailors, engineers, to housewives, each recounting their close encounters with glowing spheres. Some letters described small orange balls dancing along telephone wires. Others spoke of a ball splitting in two. One even claimed a little lightning ball came bouncing into the room after they answered a phone during a storm. Time and again, witnesses noted how quietly the ball of light moved, how it could pass through a window or wall without an opening, and the intense smell of sulphur after it exploded. Dewan's collection of stories helped establish a sort of profile of ball lightning. Its appearance, sounds, smells and behaviour were often remarkably consistent. And universally, the observers expressed a mix of astonishment and fear. This was unlike anything they had seen. Crucially, Dewan and others in the 1960s were attempting to drag ball lightning from the realm of anecdote into scientific analysis. Still, back then there were no photographs, no recordings, just human descriptions. Many scientists remained politely unconvinced. Ball lightning was notoriously capricious. You couldn't predict it or recreate it at will. So how could you study it? It's hard to blame the skeptics. After all, science demands reproducible evidence, and ball lightning seemed stubbornly unwilling to perform on command. But those who believed in its reality had good reason. Too many credible people, pilots, professors, electricians, had seen it with their own eyes. As one engineer wrote after seeing a glowing sphere skitter across his yard, people thought he'd lost his mind, but I knew that I had seen a marvel of nature and felt enriched by it. For witnesses, no proof was necessary. The experience was indelible. By the late 20th century, the question was no longer, does ball lightning exist? Most scientists grudgingly accepted that it probably does, but rather, how on earth does it work? Answering that meant finding a way to study a phenomenon that flashes into being unpredictably and disappears in an instant. Scientists began devising clever and sometimes risky schemes to catch ball lightning in the act. One approach was to go where lightning is plentiful and try to trigger ball lightning under controlled conditions. In the 1970s and onwards, researchers in the former Soviet Union, the United States, and other countries built specialized lightning research stations, essentially laboratories set up in very storm-prone locations. A famous one was in Florida, the International Center for Lightning Research. There in the late 1980s, and continuing through the early 2000s, scientists like Professor Martin Newman, a leading lightning expert at the University of Florida, literally shot rockets into thunderstorms, trailing thin wires behind them to provoke lightning strikes on command. The idea was simple: if lightning won't come to you, send a rocket to lightning. Once a lightning bolt was triggered down the wire, the team could observe it with high-speed cameras and instruments, hoping that maybe, just maybe, a ball lightning would form where the bolt hit. They tried again and again, firing rockets into storm clouds and directing strikes onto various targets on the ground. Professor Newman and his colleagues even got funding from the US Air Force specifically to pursue ball lightning, a sign of how seriously it was being taken by them. They set up all kinds of materials for lightning to strike: metal plates, soil, water pools, wood, even silicon wafers, which some theories suggested might be key. If ball lightning is created by lightning hitting something and knocking material into a glowing ball, then the question was, which material? What kind of target would yield a floating fireball? After many experiments and dozens of triggered strikes, there were a few tantalizing glimmers. On one occasion, lightning struck a stack of silicon wafers and produced a brief spray of glowing droplets, like sparks that lingered longer than usual. In another test, a bolt hit a shallow pool of salt water and a flame-like flicker appeared above the water's surface. The most promising event came when lightning struck a wet metal sheet. Witnesses saw a bright sphere form just above the metal and hover for a second or two. It was small, only a few tens of centimeters across, and it didn't last long, but it was ball-shaped and glowing. For a heart-stopping moment, the researchers thought they'd done it. They'd made ball lightning on demand. However, even that best case fizzled out in less than a second, breaking into smaller glows and then nothing. As Newman later quipped, "If ball lightning was easy to make, we would have made it." Despite the near misses, true sustained ball lightning eluded deliberate creation. The experiments did, however, bolster certain ideas. For instance, the tests with silicon and metal were suggestive. We'll come back to that. Meanwhile, others took a different approach, laboratory experiments on a smaller scale, attempting to simulate the conditions of ball lightning. Some experimenters used high-voltage machines to create plasma balls in the lab. Nikola Tesla, the famed inventor, was perhaps the first to claim success here. All the way back in the 1900s, Tesla wrote that he had managed to produce electric fireballs in his Colorado Springs lab, little glowing spheres a few centimeters wide that he could briefly sustain and even hold in his hand with special gloves to show visitors. The fact that Tesla was thinking about ball lightning over a century ago shows how long this puzzle has captivated inventors. In recent decades, researchers like Dr. Eli Jerby in Israel have experimented with microwave energy to create plasma balls. In one famous demonstration, Jerby and his colleague Vladimir Diktia in 2006 used a household microwave oven, heavily modified, to excite a piece of silicon. They found that by drilling a super-hot spark into silicon, they could eject a tiny glowing orb of ionized silicon vapor that floated upwards for a second or two, essentially a mini ball lightning in the lab. It wasn't very large or long-lived, but it was free-floating and spherical. This was a strong hint that maybe vaporized silicon from soil or sand could be a key ingredient in natural ball lightning. After all, sand and soil are full of silicon compounds, and a lightning strike creates enormous energy, enough to vaporize bits of Earth into a hot gas. By the 2010s, the hunt for evidence took a big leap forward thanks to serendipity. In 2012, a team of scientists in China was out in the field observing ordinary lightning with sensitive cameras and spectrometers. They weren't specifically looking for ball lightning, but ball lightning found them. During a thunderstorm near Qinghai in northwest China, their equipment captured a one-of-a-kind event. A bright ball of lightning formed right after a cloud-to-ground lightning strike, then floated horizontally above the ground. The high-speed video showed a glowing orb about 5 meters off the ground, travelling roughly 15 meters before it faded, lasting a total of 1.6 seconds. Even more crucially, their spectrograph, which records the light spectrum to identify chemical signatures, caught the signature of the ball. When they analysed the light, they found the spectral lines of silicon, iron and calcium. Those elements just so happened to be common in soil. It was a eureka moment. Here was direct evidence connecting ball lightning to the soil and ground where lightning had struck. The findings, published in 2014, suggested that when lightning hit the ground, it might vaporize certain minerals, silicon compounds specifically, and somehow that hot vapor formed a glowing self-contained sphere, a natural ball lightning. For the first time, science had caught a ball lightning red-handed on camera and even measured it. That one lucky observation in China has since strongly influenced how researchers think about this phenomenon. It doesn't solve the mystery completely, but it offers a solid clue grounded in data rather than just eyewitness words. So how do we explain a glowing ball that pops out of a lightning strike and drifts around? Over the years, scientists have proposed a range of hypotheses, some elegantly simple, others wildly exotic. Let's explore the major ideas and see how they stack up. One of the leading explanations today is the plasma ball theory, essentially that ball lightning is a kind of self-contained ball of plasma. Plasma is the fourth state of matter, beyond solid, liquid and gas. It's what you get when gas is heated so much that its atoms break apart into free-floating electrons and ions. A flame is a kind of plasma, and so is the glowing gas inside a fluorescent light. Plasma naturally emits light. Think of a neon sign's glow. So the idea is that ball lightning could be a plasmasphere, a pocket of ionized air or vapor that's somehow stabilized into a ball shape, allowing it to persist for several seconds. But plasmas typically dissipate quickly unless there's a continuous energy source sustaining them. How could a plasma ball keep itself going? This is where the chemical energy idea comes in. Remember the Chinese observation that detected silicon and other elements from soil? In the early 2000s, two scientists, John Abrahamson and James Dinnis, had suggested that ball lightning might be formed when a regular lightning bolt hits the ground and vaporizes silicon-rich soil. The intense heat turns silica, sand essentially, into a gas of silicon atoms. These then recombine with oxygen in the air, releasing heat and light in a slow burning reaction, effectively creating a floating ball of burning silicon. Think of coal from a fire, glowing and burning out, but here the coal is a cloud of silicon vapor, hot enough to shine. Such a ball might last a few seconds until the silicon is fully oxidized or turned into silicon dioxide smoke. This theory neatly explains several things: the brightness, the duration, since it lasts as long as the fuel does, and even the often reported smell of chemicals or ozone. Hot silicon would scorch the air and anything it touched, producing odors. It also explains why ball lightning might appear after a ground strike and near the ground, where the vapor is. The burning silicon model gained a lot of support after the 2014 Chinese study because the data fit really well with what Abrahamson and Dinnis predicted, but it still seems to conflict with various accounts of ball lightning passing through walls. Another major theory involves electromagnetic energy, essentially microwaves. In the 1950s, the Soviet physicist Pyotr Kapitsa proposed that ball lightning might be microwave radiation trapped in a bubble of plasma. Imagine lightning strikes and somehow creates a brief, intense burst of microwave frequency electromagnetic waves. If those microwaves got trapped in a sort of spherical cavity of ionized air, they could bounce around inside it, continually heating it and keeping it glowing. The size of the ball would depend on the microwave wavelength. It's essentially a standing wave of energy, making a little plasma bubble, so the theory claims. It's appealing because it provides a power source to keep the plasma hot, the internal microwaves. But it requires a way to generate and confine those microwaves naturally. Kapitsa was not the first to wonder whether ball lightning might be sustained by microwave energy. In 1943, a Mexican physicist named Manuel Cirillo attempted to test a similar idea experimentally. Cirillo proposed that intense microwave fields generated by lightning could create and maintain a glowing plasma in air. In laboratory trials, however, the plasmas he produced were short-lived and unstable, collapsing as soon as the external energy source was removed. They did not reproduce the persistence, motion, or self-containment reported in real ball lightning sightings. As a result, his work suggested that while microwave energy can create brief luminous effects, it is unlikely to be sufficient on its own to account for the phenomenon. Later microwave-based theories, including Kapitsa's, revived the idea in more sophisticated forms, but they face the same fundamental challenge: how to sustain a stable, mobile plasma in open air without an obvious ongoing power source. For that reason, microwave models remain intriguing but incomplete, and have not become the consensus explanation. Then there are the internal energy theories. One sensational idea once floated was that ball lightning could be a naturally occurring thermonuclear fusion reaction, basically a tiny sun on Earth, fusing atoms and releasing huge energy. This was highly speculative and was largely dismissed because there's no evidence of the kind of radiation or aftermath such fusion would cause. Another wild hypothesis suggested that perhaps ball lightning are tiny black holes that pass through Earth, gobbling up a bit of air as they go and emitting energy. A serious stretch of the imagination, and needless to say, not supported by observations. A more grounded but still exotic line of thought in recent years involves complex electromagnetic knots and vortexes. For example, some physicists have proposed that ball lightning might be a sort of toroidal electromagnetic knot in the atmosphere, essentially a self-contained donut of magnetic fields trapping plasma inside. In lab settings, scientists have created structures called plasma toroids in ultra-cold gas that behave a bit like knotted electromagnetic fields. The idea is that maybe lightning could tie a knot in its own magnetic field that persists for a while, confining a hot plasma ball. This is highly theoretical, but it's an active area of research. It could explain why the ball stays together without an obvious energy source. The energy is stored in the electromagnetic fields in a stable configuration, for a short time at least. Yet for all these hypotheses, none has been conclusively proven as the cause of ball lightning in nature. Perhaps multiple mechanisms are at play. Ball lightning might not be a single phenomenon at all, but perhaps different phenomena that produce similar effects. For instance, maybe sometimes it is burning silicon vapor, especially for ground-level balls after lightning strikes soil, while other times, like balls that appear high in the sky or inside aeroplanes, it might involve electromagnetic fields or even charged plasma from the lightning channel. This could explain why one theory alone struggles to cover all cases. After all this explanation, it's time to ask, so what is the most likely explanation for ball lightning, according to today's science? We may not have a definitive answer, but the evidence is pointing in a promising direction. The silicon-based chemical plasma theory stands out as the forerunner. The pieces of the puzzle fit together. Lightning strikes soil rich in silicon, like sand or clay. The intense energy vaporizes some of that silicon, along with other minerals like perhaps carbon, calcium, etc. This forms a hot plasma cloud of silicon vapor. The vapor, being hot, immediately starts to oxidize in the air, much like a sparkler spark, but on a larger scale. The burning plasma clumps into a roughly spherical shape, perhaps via some electromagnetic self-attraction, or just the expansion pattern of the vapor. The glowing ball is sustained for a few seconds by the energy of the ongoing chemical reaction, silicon oxidizing to silica, plus maybe some leftover electrical charge. Once the silicon is consumed or dispersed, the ball fades away or sometimes explodes if the ball's structure destabilizes rapidly, which could happen if, say, it cools and collapses, inducing a quick magnetic field collapse or a mini pressure wave. This scenario aligns well with what was captured on video in China, a ball forming at the ground after a strike containing soil elements. It explains why many ball lightning incidents occur near ground level and often during active thunderstorms, with cloud-to-ground strikes. It even accounts for the common observation that ball lightning sometimes moves against the wind or independent of it. As a hot ball of plasma, it might be guided more by magnetic fields or momentum from its creation than by the breeze. As for how it could enter a house through a closed window or wall, the silicon plasma idea would assume it didn't literally pass through solid glass. Instead, perhaps a fragment of the lightning strike, like a hot jet of gas or a discharge along wiring, penetrated into the house and then formed the ball indoors. For example, lightning might strike the ground right outside a house, and a ball of glowing vapor swirls in through a small gap under the eaves or down a chimney. To an observer, it seems to materialize from nowhere inside the room. It's either that, or those particular reports are exaggerated. Physics does have a hard time with the idea of matter passing through walls intact, unless the ball is not made of normal matter, which brings us back to exotic ideas we've mostly set aside. The microwave theory still has its proponents too. Some think it could work in tandem with the chemical model. The lightning strike creates the plasma and simultaneously emits microwaves that help keep the plasma ball energized for a brief time. In fact, the slight 100 Hz oscillation detected in the Chinese ball lightning's light intensity hinted at some external influence. The researchers speculated nearby power lines could have been a factor, so there may be electromagnetic energy giving an extra push to the process. Ongoing research, like that of Professor Human's group and others, aims to confirm this by creating stable plasma balls under controlled conditions that match eyewitness accounts. We're getting closer. Experiments have produced ball lightning lookalikes, albeit smaller and shorter lived, and computational models are starting to replicate how a ball might form and last a few seconds. But even with a likely explanation emerging, ball lightning hasn't entirely given up all its secrets. Why do some strikes produce it and most do not? It might be a 1 in a million occurrence, when just the right combination of soil content, humidity, and electrical conditions align. Why do colours vary? Maybe depending on what elements are burning. For example, sodium produces orange, copper produces green, etc. And could there be different flavours of ball lightning, some more electrical, some more chemical? These remain open questions. Even as science edges towards answers, ball lightning remains at its core an enigma, one that straddles the boundary between wonder and reality. For the everyday person, it's not the equations or theories that captivate, it's the image of a floating ball of fire appearing out of a stormy night, doing a ghostly dance through the air. It's the human drama of these encounters, the stunned homeowner in her kitchen, the frightened pilot at 30,000 feet, the monks and villagers of old who could only call it a visitation of angels or devils. In our modern understanding, ball lightning is a natural phenomenon, not supernatural, but that doesn't make it any less amazing. If anything, knowing that the laws of physics, with a dash of chemistry, can produce something so seemingly magical only deepens our appreciation of nature's creativity. These luminous orbs are a reminder that the world still holds surprises we don't fully grasp, that even something as familiar as a thunderstorm can spawn a mystery. For those who have witnessed ball lightning, the memory often feels almost spiritual, fear, awe and beauty all mixed together. One contemporary witness described the orb she saw in her living room as like a bad special effect. It almost didn't look like it belonged in our world. A moment where reality itself felt edited. Others, once terrified, later reflect on how lucky they felt to have seen one of nature's rarest spectacles. And rare it is. You could live 1,000 years and never see ball lightning. Statistically, only a small fraction of people ever will. Ball lightning may be nearly tamed on paper by theories and experiments, but the experience of it, that will always be a little bit magical, a little bit unknowable. It reminds us that not everything is fully under our dominion. Nature still holds some wild cards. Thank you, dear friends, for listening to The Mystery of Ball Lightning. If you enjoyed this, feel free to leave a comment. What do you think is the most likely ball lightning explanation? Do you think any of these theories adequately explain it? Have you seen ball lightning? Leave a comment and let us know. You can also feel free to like the video as well, of course. That always helps us out greatly and is tremendously appreciated. I'm currently releasing these episodes twice a week, so there's plenty more mysteries and fascinating topics to delve into, and there'll be another one coming your way very soon. Many blessings to you, and if you're heading off to sleep, then I wish you very good night, and of course, very sweet dreams.